Hi, this is Glenn Jarvis. Welcome to Red Pill, Blue Pill. This is a very informal screencast. What we're doing is just recording. First of all, I'm practicing a talk, but it's also helpful so that we can later be able to, if you've never experienced virtualization and you want to get used to getting started with Amazon, or if you're interested in how Python works with some virtualization environments, this might actually work out for you. We will go through a couple of practice scenarios where you actually can see us connect to Amazon. We will show you how to do that with a programming language of Boto, and then we will actually look at how virtual environments are working. But before we start, I think we need to kind of unlearn a couple of things. One of the biggest problems that people have, in my experience with virtualization, is that they immediately think the word virtualization means virtual hardware or hardware virtualization. I think because we've done such a good job with VMware, VirtualBox, QEMU, Parallels, we get so focused on hardware virtualization and the different types that we actually don't think of virtualization in the more broad sense of what it is. I mean, we've had virtual memory since the 1950s, and we've been talking about it since the 1940s. So there are definitely things that we need to keep a broader canvas when we're talking about virtualization. And in the scope, what I mean with virtualization, it is, and I'm pulling this information from Wikipedia. The reason for pulling it from Wikipedia is it's the same concepts we talk about from many sources, but it's kind of condensed into one syntax, one ontology. So if we just use Wikipedia and use those definitions, it'll be easier for people to follow. So the basic definitions are, in computer, virtualization is the creation of a virtual rather than an actual version of something, such as hardware platform, operating system, storage device, network resources, etc. So like we said as an example of a few moments ago, virtual memory is a type of virtualization, not as an exciting new type for many people as the hardware virtualization that's becoming so exciting, but still something that's very useful. So again, these definitions are coming from Wikipedia, and these are the different categories of virtualization. We're only going to briefly hit each of these, and then we're going to give demonstrations on the two that you see listed here. So hardware virtualization is the kind that we're talking about first, where we basically say, I have a computer that I want to, I have a machine and I want to basically be able to use that machine in other ways. I want to have a guest machine, pretend not even know about the hardware, and have that hardware be virtualized. I'm not saying that well, so let me try again. I want to be able to run an operating system on something that may not even be a real machine, but a virtual machine. And we see people do that a lot. We're going to use the Boto library to show how we can use Python in these ways. And we're going to connect to Amazon and use some free resources from Amazon to get hardware virtualization. So that will be our demonstration there. Desktop virtualization, this is the concept sort of like what Chromium laptop or the little Chromebooks are to Google, but not necessarily just web-based. So the idea is you have a very thin client, and that your desktop, your Windows laptop computer, or your desktop wherever it is actually sitting somewhere else in a centralized room, kind of like we saw with Novell ages ago that boot from the network. Next we have software virtualization, and this is another really cool and interesting piece because we've seen this for a very long time with BSD. Like FreeBSD had software jails, which were such a clever way of using software virtualization, where the actual operating system itself kind of has a little mini version of the operating system inside of it. Even though it's not virtualized on hardware, it still has a little mini version of the operating system inside of it. Even though we aren't talking about just operating systems, but just environments, virtual environment is the same thing with Python, where you have a version of Python that you might have several different versions of Python running on the same machine. And we'll go over virtual env in that example. Memory, we've known about virtual memory for a very, very long time. Most of us have taken an operating system class and say, okay, my program is going to ask for a memory location. That's not the memory location I'm actually going to get but my program doesn't know the difference. As long as my program can act and say, okay, I'm writing to this memory location and it uses that particular address, then as long as it writes back to that address, everything still works. And through magic of the operating system and some very, very clever algorithms, memory is being moved around behind the scenes and needs to be being virtualized, so it's not even in memory at the time, but swapped out on disk. So we won't talk about virtual memory, but it's something that we've seen virtualized for a very long time, as of storage. Memory and storage both we've seen, large SANs, and the idea of having a disk look like it's a bigger disk with multiple disks or RAIDs, or just all kinds of things could be concepts we could talk about with storage, but we're going to pass those off for now. With data, the idea of virtualized data is kind of, in my opinion, I could be wrong and get comments on this, but I think of it more of the semantic web, where you're extracting things away into resources, and so whether that's real or not, it looks like from your data API point of view, it all looks to be the same, even if it's a hodgepodge behind the scenes of data and how it works together. And network virtualization is actually quite interesting because we have virtual networks all the time. We've had VLANs as part of the networking protocol for quite a while, but until you've actually used a VLAN and how you can have a network with two complete virtual networks inside of it, but still running on the same actual network, is a very, very clever way of virtualizing something that's quite physical, actually. But just because the protocol actually knows about your VLAN number, you're able to compartmentalize and separate your networks into two networks, even though they might be physically the same network. Anyhow, we are only going to talk about hardware and software virtualization, simply because there's only so much time and there are a lot of cool topics here. So hardware virtualization is BOTO. So let's jump over to look at some things about hardware. Quickly, some definitions, and I won't spend too much time here so we can get to the Amazon presentation. But basically, full virtualization is the kind of virtualization that I think most people are hung up on when it comes to what is virtualization. It's the stuff that we see, like the VMware's running, or the type of programs running in our desktop. It's where the software is actually pretending to be hardware and it's not passing through. Now, the good thing about that kind of virtualization is you can have flexibility. You pretty much are able to pretend to be, you can run any operating system you want because the operating system doesn't know you aren't a real machine. But because we're emulating hardware, that by its very nature is going to be slow. So we have a trade-off for performance. Paravirtualization, on the other hand, is the hardware is not simulated. Basically, the guest operating system needs to know they're basically compartmentalized into different domains, but they actually get real processing time on the processor. There are a little bit of changes that need to be done to the guest OS just to kind of to make sure they can handle things properly down on that level. Maybe I shouldn't jump into this just now, but when you get into the processor, you know that you have certain instructions that can be run by just anyone. You have some instructions that can only be run in a very privileged mode. And you can have another set of instructions, especially for those processors that hardware that's now aware of virtualization, that can be done, that's kind of this virtualized kind of world, that I can be kind of a virtualized kind of statement. Anyhow, the guest needs to be updated a little bit so it can run, but basically that means you can have one particular machine that's it's your main, your domain 0. It's your main kind of controller of what this thing is, and that main controller, this domain 0, can install and know about and help control and pass off configuration, if you will, to different types of domains and different virtual machines. But each of those machines get real time. Very much like if you look at a multiprocessing, if we look at computers running on our operating system, computer programs running on our operating system, those processes, they aren't running at the exact same time, but they certainly look like they are. They're being swapped in and out and being able to share their processor. Similar conceptually, that you're actually able to see that these particular different virtual machines are being able to share the hardware more directly. So you have speed comes in quite often. It's much faster. But again, the trade-off is you have to do a little tweaking in the guest OS to make sure it knows about such a thing. And then partial virtualization is kind of the half and half of the above. At least some part of the guest needs to know that it's being paravirtualized. I used the word host and guest so interchangeably I didn't even stop and define this vocabulary. Let's just stick with the top two so we can move on to the presentation through the Amazon piece. The host is the guy who actually is the virtual computer, if you will, or the virtual thing. It's the thing that something is, the actual machine, the thing that's running another thing. So, for example, if I have my laptop, and my laptop has Windows installed on it, and if I have inside of my Windows program, I have a machine, let's say VirtualBox, and inside of VirtualBox, I have Windows. Then I have the inside guest, which is the inside Windows program, and the outside host, which is the actual my laptop that's running everything. We don't have to use, I don't actually have a Windows machine, but I do actually have a, I have a Mac, and in my Mac I'm going to actually start VirtualBox, and I have several operating systems I can start. So if I start this operating system, now here I happen to have a Windows program that's just like any Windows program, it doesn't know the difference, running on my computer. So I can actually have my typical Macintosh that you see everything at the bottom, you see the typical Mac stuff down here, and Windows stuff here. Windows is the guest, the actual host is Mac, but we can have any configuration of those things. We're going to use Amazon to be our host. We're going to basically say we're going to start machines up on Amazon, and we are not even going to, they're going to be handling all of that stuff for us. And so we will use a website to connect to them, to actually start machines, stop machines, configure machines, log into machines. And when we're done with that, we will actually learn to do the same thing with Boto. Okay, so it's just a quick overview of where we were. So let's go ahead and go to the Amazon demonstration. But before we go too far, just know that I have videos that I have a PDF document that I can give you. And that PDF is just stepping through what we're doing. So if you just look at the PDF and download it, it can help you step through these different screenshots, especially since, or I can give you a website, because these screenshots change all the time. After this video, this screencast is done, Amazon will be changing the interface a little bit, and so it'll be slightly different. So contact me, I'll help you get started with that. But let's go ahead and just go over and get started with Amazon. If you're watching a screencast, now it's been about 15 minutes, might be a good time to pause and take a break so we can start a new concept. Alright, so we are at Amazon Web Services, and so you get to this through just aws.amazon.com, and once you log in, you will let it be at a screen very similar to the screen that we see here. So you will probably have something slightly different just because time has gone by, plus I've configured things just a little bit. Here are my services that I can go to, and each of these particular services are in menus so that it's easier to get to. But I also can edit my menu at the top and place the things that I like the most. Like, for example, if I were to use this thing, I can put it up on my menu and then it's available for me. The two I'm going to talk about, or at least the two that are probably going to be relevant I won't have time to talk about, are EC2, Elastic Compute Cloud, which is that whole bunch of machines that we can, a whole bunch of guest machines that we can start and run on Amazon services, and Route 53 so that I can update DNS dynamically. I really like this. It's probably the best way to be a programmer and control DNS. If I'm starting a brand new machine, I still have to go in and change its DNS entries to mapped IP addresses. That would be just such a bear if I didn't have a way of doing it programmatically through an API. Probably I haven't decided to talk about Route 53. It wasn't planned, but if there's time, we definitely will do so. But EC2 is the real focus for today. Again, you will want to sign up for Amazon. Don't worry about giving your credit card, because if you follow the instructions from that PDF document that I created, you won't be charged. But you have to follow the instructions very clearly. For example, make all the choices that I point out to make. Amazon has a program where you get to make free instances for the very first year. And if you use just one instance, but if you have one instance, you use the right kind of type of instance, then it'll be designated with a star, and you use the right size, Amazon will give that to you for free. And it's great for a demonstration like this. After 1 year, you will have to pay for it, but we are only talking about a few cents an hour. Very, very even less. So I will go to the Instances tab, and we can see that I actually have an old instance that stopped that I probably should have just deleted before we started here, because we're going to be making new ones. Okay, so the code demo is gone. We only have one instance here, and that's my quote-unquote production instance for running things. So before we start, we basically need to launch an instance. That's how we get started. So when I click Launch Instance, I will have several choices. The first choice is the classic wizard, which gives us lots of options. The second choice is a very quick launch wizard. Once you know what's going on, you might want to just hurry up and choose something and make it start. We won't do this because several things are done for us that we want to learn about and or avoid. And the AWS Marketplace, what this is other people have made software and they've installed it on the virtual hardware, so that if you don't want to go through and find this software and find a machine and install that software on that machine, you just want to be able to get that software to run, you can just find that software. Let's say it's Oracle, or let's say it's a certain flavor of Postgres with certain configurations. You can find that software and what you pay, and it will just start already configured in that manner. And so you're consuming that as you're consuming the time of using that software. And so the person who made it will get a portion of your time that you're paying for, and Amazon will get a portion of that as well. We are only going to use the classic wizard for this demonstration, and so we'll click Continue. Now from this point we have several options. Notice that we have Choose an AMI, Instance Details, we'll have several screens of that, Create a key pair, Configure the firewall, and then Review your changes. So this is what we're going to do. Of our choices for choosing an AMI, we have to figure out what is an AMI. An Amazon machine instance, it's basically the flavor of the machine that you're going to start. More importantly these days, the flavor of the software that you're going to have. So for example, if you're going to install a CentOS machine, you would probably want to find the CentOS version. If you want to install SUSE or Windows, you would find those, as we see SUSE listed here. We see Windows Server 2008 base listed here. The list will be very different when you look at this because it's constantly being updated. Although these do seem to be the top of the list most of the time. Notice the free tier eligible if you use a micro instance. Again, I have a PDF that you should be able to get that will step you through screen by screen if there's any concern at all, but it is pretty straightforward. The stars are the ones that are free if you choose the right options. So we're going to go ahead and choose Amazon Linux AMI, and the reason why is that this is I'm a CentOS person. I very much like the enterprise CentOS Linux environment, And this is a spin-off of that. It is really just the same thing, but packaged with Amazon does some extra packaging and keeps things cleaned up, which makes things easier and automatic for you as we're working through the process. So this is always my favorite choice, but you're going to have a flavor I'm sure you already want to pick. It doesn't really matter for this demo if you pick something else, that's great. I'm going to leave it to be 64-bit as the default choice, and I'm going to click Select. So now we've chosen an AMI, and now we're going to choose some instance details. Now, the number of instances I want can be 1 or 500, but only 1 is free, so let's stick to 1 today. The type, we've lots of choices here. We can go for very, very huge, high I/O, quadruple extra large, 60 gigs of memory, but probably a little overkill for this demonstration, and a little more expensive. I'm going to stick with the free tier eligible demo, so always micro is free, and the reason we're just going to be spinning it up, tearing it down, and micro is just perfect for that. And the reason Amazon gives you micro for free is a chance to get you to use the services, and then after the fact, if you like the service for free for a year, you're probably going to be hooked and start using more advanced services. Now we have a choice of what type. EC2, what type of availability? Where is that machine that this is going to eventually run on? Where is that host machine going to be located at? My choices are mostly going to be things in East Coast. And frankly, I don't care for this demonstration, and probably wouldn't care that much unless I got into a really specific production environment where I want to make sure that I had machines spread across several data centers in case a hurricane came into one, those kind of things. But for now, we'll just choose Continue, and we are still at Instance Details. Now, in Instance Details, we have several other choices that are going to come up. One of them is a kernel ID, and the other is the RAM disk ID. We're going to leave the kernel and RAM disk just default. I don't need to change any of that stuff that I get automatically for free, and for this demonstration, it's just easier to let it go. Monitoring, notice that additional charges will apply, but if we wanted extra monitoring, not just the normal stuff, but extra monitoring, we could check this. I will leave it off. Here in the user data field, this is where you would actually type to put your program if you wanted things to happen automatically. Let's say that you wanted to have to start a program through to use wget to pull a program off the web and then start executing it. And maybe that program's a self-install, or maybe you want to configure things to use more sophisticated mechanisms like Chef or Puppet instead of using this user data box. But the point is, it's completely configurable so that once the machine comes up, not only is the machine up, but it's actually up and running programs automatically. Everything should be as automated as possible so that you don't have to be hands-on at all. That's the purpose. So that this entire, I've known some companies where entire environments were spun up completely. Their entire production system is spun up as a complete another instance of everything. All of their operating system tests, all of their operations tests are run. All errors are reported, and then they tear it back down immediately. So pretty much they can see what their production deployments can be like, because they can deploy an entire new production environment, switch to that production environment. If things are great, great. If not, we can switch back to the old one. But typically, they don't have many problems because they've tested things so thoroughly that their new production environment will work just fine. Lots and lots of choices once we start getting into this type of cloud stuff. All right, shutdown behavior, I'm going to let it stop. If I were to say terminate it, then basically I don't need to throw the machine away once it finishes. Maybe I want it to run a job, report that job on the web, and then throw itself away. But I'm going to choose stop because for me, I like it if I am paying for something that's being charged, like for example, larger than a micro instance. But I don't need the machine running all the time, just once every 12 hours, run for 5 minutes. Or that's a bad example since there are other things we can do like that. But let's say I just want to run it once when I have to process something for class. I can start the machine, do things and turn it off. And if I just use basic configuration with no special DNS, then I'm not charged for it being off. There is a limit to the number of machines I can have, though. Regardless, we're still on instance details, and we're clicking next, and this is the hard drive for the particular instance. So since I'm running out of time talking too much on this, I will go ahead and skip the hard drive, but obviously I can configure different types of information for the drive and have different choices and add extra drives. Now I'm going to name this instance, and this will be, I will just call it Demo1. So we have Demo1 as an instance. And now for this particular, I've already created a set of keys. This presentation will be given for a group, and so I've given a key with that group's name on it, called AWS Bay Piggies Demo. It's the Bay Area Python Interest Group. Great places to meet with other people who know Python and like to learn more about Python. So this is the pair of SSH keys, and typically I have a key on my system, which we already have downloaded. To save time, I've gone ahead and had this key down on my desktop, and we see that the key is an AWS demo. So here's my key that's going to connect to this machine if I choose that key. Okay. After creating, or in our case just choosing, a key pair that already existed, after we create a key pair, we now have a choice of configuring the firewall. The firewall is actually a choice of different machines. Basically, they call them security groups here, and it's called firewall here, but it's basically the concept of a firewall. So I'm going to use a firewall that I already set up, again for the demonstration. But if I wanted to change configurations, if I wanted to open different ports, things like that, I could do that later. But for this, we're just going to say this is the demonstration, here's the firewall. And finally, I get a chance to review. So here's the AMI I chose, here's my Linux instance, a description. I can edit a few things now, number of instances, but I'm going to go ahead and just launch that instance. And now I can get another splash screen and say, great, while that's running, you can do a few other things. But we're pretty much done. We know we've now started this particular machine, and the panel up here is the machine. And every time I click on a panel up here, the details down here change. So we see that this particular machine now has an IP address. This is the public DNS name that's automatically generated for that machine. So I could start getting ready to SSH to it. In fact, it's already running, so I should start SSH to it now. Let me get to a terminal. Okay, so now I'm in this terminal. One of the first things that you want to do if you're doing the video or the PDF document, make absolutely certain that these permissions are correct. If you are too permissive, for example, if I had an extra group able to read on this key, then I will get this really bad message that says, you know what? You're not allowed to use this key, it's too public. In fact, I will leave this so we can see the error for a few minutes. Now I'm going to SSH to the box that we created, but I'm going to use the -I option to basically say this is the identity of the machine we're trying to get to. So basically the identity of the key, I mean. So this is the key. And the machine we're actually going to get to is the machine that we just saw, we copied from the terminal, the window screen a few moments ago. But I know that particular AMI needs that username for that key. Okay, now don't forget, we're expecting a really nasty message that says, wait, your group's too big. You don't have permission to do this. I will go ahead and continue giving over permissive options. So now everybody can read it, just so we can see, hopefully, a really bad message that says, no, don't connect. We're trying now. And like every demonstration, something's wrong. Has anyone caught what it is yet? Because I don't. Let me do some diagnostics real quick before I realize I've done something stupid. DNS is not found. Okay, let's assume it's something on my end. Hopefully someone will be able to edit this out of the video because it's quite boring to watch me just try things. And just because we've seen enough go bad, let's take off the stuff that we know is wrong. I don't care if you see this private key. If you're that good to type it in from a video, good for you. It'll be deleted before you even see it. Ping probably is turned off as an IPMI, so that's not helpful. How are we doing in time? Half over. AWS please demo. Let's make sure that port's still on in the firewall. I'm not sure what could have changed it. At least now you can see how things change in troubleshooting. I've used the same before. I would be very surprised this not turned on. However, I don't see 22 turned on. How the heck did I get that to work before? Okay. Yay! So, the lesson there was my security group didn't have 22 port turned on, so I was stuck at their firewall. So, how did I find that? I just looked at the security group, as we saw here, and the security group we made for this did not have the SSH port. I was sure I've done that in the past, but apparently not. Okay, we will go back to our instance. The actual instance IP DNS name is... So real quick, as a neat recap, since we had that mistake, I'm going to SSH to AW. First of all, the -I says, what key, what identity am I supposed to use? So it knows how to connect to that machine. So this is my secret key that's going to connect to that public machine. And this is the username and password. The username I knew because of this AMI has an EC2 username. Depending upon the packager, it might be different. It's whatever username was used to create the key. And the DNS name came from the DNS that we see down here when we looked at the machine that we created. So it took us longer to connect to the machine than it did to create the machine. First time connecting, I say yes, and sure enough, I'm now connected to this virtual machine. It was actually quite painless, except for my mistake of the firewall, and that uncomfortable time there was basically me not realizing the firewall of port 22 wasn't open. But I have a machine, and my first Python program for the demo. Hey, it's now a Python, now it's a Big Piggies or a Python demonstration. Great. One of the first things we would ever do, if you are an administrator for any box, is you want to make sure that you apply your updates. You're told right here to run sudo yum update to apply all updates, and I suggest that every time you build a box. In fact, it's one of the things that we should put into that little user space where we had a chance to make a new box, and it says here type in some user data, user text. Yum update should be one of the first things we do when we build a box, so that we get security updates as well. Okay, as we're talking, it's almost already installed, so if we give it another couple of seconds, we probably don't even have to go away, but we have now built a machine and updated the machine through Amazon's virtual interface. Okay, that is taking a few moments, so we'll just let that one run. And that's this part of the video. So we had a couple of things. One, an overview of how we were doing things. What was virtualization? Okay. Next was how to build your own virtual instance with Amazon. Pretty straightforward. With this video, with the PDF that I have for you, anything you Google, it should be pretty straightforward to make one, and if you've never used this before, make one for free. So, at least for 1 year. So I would pause the video, and the next thing we're going to talk about, if you want to take a break, is how to do this all through code. Okay, so that's about 39 minutes in, so we now are going to do the next piece. We are actually going to use some code snippets. And we're going to do almost the exact same thing we just did, but we're going to do it. Oops, wrong demo. Now we're going to go to Bsd. So we're going to do almost everything that we just did, but we're going to do it through code. And I will give you these libraries. this little snippet of code so you can learn how to do it not just through the web interface, but how to do it programmatically, because that's really what our purpose is we're trying to learn how to do this completely hands-off. That's the purpose of cloud. Although it is nice to have this web interface so you can make a machine just for testing, for example, and then tear it down when you're done, or just stop it until you have to run another test. Okay. Be warned that the other things, like if you make your own static IP, you're using something called elastic IP, then you will have to be charged. You will be charged for that, and stopping it will actually cost you more money than just leaving it running, because that elastic IP won't be associated with the machine. But if you just do what we've done here, it won't cost any more. Okay, so I'm going to make my first Python program, and we're going to use the Boto library. So Boto comes with an EC2 connection, and we're going to import EC2 connection, and we're going to use it to build a connection to the same thing we just saw. In fact, the window is still open on the left, so we can actually see how to change or see what changes as we go through these programs. I'm going to do a sleep. I don't remember why, but I'm pretty certain that's why the time is in here. We'll see that in a few moments. And then I have made another file with my private information in it. You will need in Amazon to figure out from the interface, or we can help make videos of that too, or screenshots, how to get a security username and a security password. Not for accessing the account. It's actually a secret. It's an API key, basically, an API secret password key. And mine are stored in private, so I don't have to actually show them in my code here. Okay, the things that we're going to, basically the name is what we're going to see here in the name column. So I'm going to call mine, I will just leave it this name. There's another machine there with that name in this particular demo, so I'm going to say that. The AMI is the same one that we picked up earlier. I already looked it up and tested that for you. The size is T1 micros, so it stays small. However, I've noticed that this is creating small instead of micros, which there will be a charge for. So if this still gives us small instead of micro, we have a bug to figure out. Probably with Amazon or with Boto, or I might have somehow made a mistake here. Maybe it's not Unicode, I'm not sure. The key name, this is the name of the instance that we will be using. So this is the Amazon BayPiggy demo. That's the key that I have already created that we saw earlier. So since it's already created and it's downloaded, this is just the key name for building the instance. And finally, the firewall is the one that we saw, sadly, didn't have port 22 open, and I'm not quite sure why, since I got this running before. I think I just forgot to test it. Testing is good. So these are the things that we're going to use, and the code is very straightforward. Building a connection with EC2 connection, and really all that is passing in the key, the AWS access key ID, and the AWS secret access key. Both of those are what you would get from the website. When you go here, you will actually see that you have a chance to go to security credentials. So security credentials will help you find those. You probably will have to authenticate yourself again to show that that's really good. Now, building an instance is done inside of a reservation object. So to keep things clearer, I've called this variable name reservation. And the connection has run instances, and run instances will return a reservation for the instances that you're going to run. So the first thing that goes into run instances is AMI. Next is the minimum maximum count. We just want one, so we'll keep them there. Key name, as we saw above, and the security group. Pretty straightforward if you take this and copy and paste. This is why I sleep. To try to demonstrate what we were doing, instead of just starting up, I want to show you that we can actually query for the statuses of it. This first moment, and this very, very first one was me being a little extra pedantic. There is a little bit of a race condition. It's a very small one, but just to avoid it for this demonstration at least, I'm just sleeping for a second while we don't see instances in the reservation. Okay. our instance is going to be the first instance in the reservation, and since we only have one, it only makes sense to pull the first one off. We obviously get a list of reservations back, a list of instances back in our reservation. And then we're going to add the tag name. So this is done after the fact. So our instance is the actual instance we created, and then we add the tag name with the name that we created earlier, which was this code demo 1A. Alright, and then basically we're looping through and checking the state. So while our instance is not running, I'm just going to immediately, in a very tight loop, print out what our state instance is. So if it's not running, just keep printing it out. So if it never got to running, this would be an endless loop. Alright, so if all goes well, Python demo 1, how quickly can we actually build an instance? We'll look in the left window. Ah, great, let's talk about virtualenv. Lots of different environments. We haven't got to virtualenv yet, but one of the things we can do is choose different virtual environments, and I want the one that Boto's installed in, so let's do this again with now Boto's available to me. Okay, so its machine's running. We're still in pending state. I don't even see it yet in the web browser, but we're in pending state over here. So refresh the web browser and let's see what we see. And it is pending. Why don't I see the A? I wonder if it's too small. Interesting. Did I not get that saved? I guess I didn't. So we have two with the exact same name. That's okay. I coded around that in case it happened in my next demos because I figured it would. Because I make mistakes. Okay, so if I wanted to do everything I just did in the web page, I now can with this little snippet of code we will share. Alright? Pretty simple. Now, moving up. We're moving to the next level. We'll keep things a little bit more sophisticated because I cannot seem to remember to, I'm doing Python 3 a little bit now, so I need to remember to put my parentheses around my prints. Everything else is about the same. I'll make a connection. I have a couple of states, stopped, running, and terminated. And now, I'm going to go through every reservation in the instances. Oh, it's good that I kept the name the same. Otherwise, this code would have broken. Oh, I gotta remember that. Alright, so for every instance in this reservation, so basically I'm going through all the reservations first. I only have one reservation. Get all instances tells me all is set by reservation. And then inside of every reservation, I'm going to look for all the instances for my reservation. I have one reservation and one instance, so for me this is pretty simple. The name is, I'm going to basically get the name of that instance. So instance.tags.get, name, default of none if it doesn't exist, and if the instance is running and the name's the name, see earlier I said in case there was a mistake, if they both were running it would give me 2, but now I have 1. So my demo instance is actually going to be the one that's, we're going to, not the most efficient, but we're going to basically go through all of the instances and all the reservations and pull out the one where it's running and has the same name. Okay, so now we're going to print that the reservation, the instance, make sure and the name, but within 25 characters so that it all lines up on the screen nicely, and the instance state. Okay, so we should basically so we have the same screen, pretty much. So we have the 2 prods that were there before, the demo that was terminated that hasn't gone away. This will delete itself after a while. The demo 1 that we created earlier, and the Bay Codes demo. So my update happened. You know what? I'm going to leave this window open for a second. This is the demo 1 that we connected to earlier. And I am going to terminate that guy. Yes, please.
This guy is now going for a shutdown. He turned it already. I'm finished. So it's cleaning that particular virtual machine out. So if I still look at this again, I will see it's shutting down. The state has changed. Alright, so we can pretty much start getting away from the website. We can see what's there by querying it. We can actually start them up dynamically. Now let's look at the next level. Again, we're building on the previous things, so pretty simple, but we're going to make a little very inefficient function that says get our instance. It's going to basically step through all the reservations and all the instances with all the names and find the one that's running with our name on it and return it. It's pretty much the same thing we did, but in a function. And now we're going to do pretty much what we did in demo 1, is we're going to loop through each of these guys and print the state. And the demo instance is our instance. We're going to print that on the screen, and then we're going to print the states out. So I threw in a loop for stopping. Because it's not stopped yet, I threw in some time just to be able to see what was happening. I think I have a bug here. These have not been tested except for right before. Nope, it's not a bug. It still is stopping. So this guy is still in stopping status, even though he kicked us off, they're still doing some stopping. And now it stopped. So you notice that I can get, the API gives me a lot faster data than the website. And stopped. Okay, so there's that. Now for demo 4, we're moving up. We can stop, we can start, we can stop, and we can print a list. Now what we want to do is we want to be able to gather some metrics. And so we have a whole list of metrics on the screen. Basically, this is what's available to you. So notice that we're importing something new. We're now importing Connect CloudWatch, not EC2. So we're connecting to CloudWatch, the same password. Throw a debug of one in, I'm not sure why. But we're connecting with a username and password. And then this metric, we're actually going to list all of the metrics available to us. So basically, for metric and connection.listMetrics, print the metric out. And that's what we just saw a few moments ago. These are the type of metrics that we have available to us. We can do volume writes, network out, volume queue length, lots of things disk related, lots of things instance related, and let's learn to use these properly. Okay. Demo 5, same thing, we've connected to CloudWatch, and now we're going to query from basically now, 7 hours ago to now. And what we're going to do is we're going to say for every metric in our list, very inefficient, we're just demonstrating. For every metric in our list, if that metric is CPU utilization, then we're going to care about it. Otherwise, we won't. We're going to pull out the instance ID, and then we're going to query the data points from the last 7 hours, and what we want to make sure we query is the minimum, maximum, average, and percent. We're going to pull, well actually minimum, maximum, and average, and we're going to pull that data and deal with it. Now we will iterate over those data points, printing out the instance ID. Okay? You can see I printed out the minimum, the maximum, and the average, And these systems are incredibly not busy, which is okay. It got a little busy right here for some reason. Okay, so I can pretty much start querying. At this point, I can do things I could have never done before. Not only do I have a cloud instance, I'm actually now able to write scripts and pull data out for that cloud instance, and I would have had to do some tops to files and other things, and I kind of did all of that for free. This last one is an example of not just the metrics that you have available for your disk or your CPU or your database hits or the number of times you've accessed your DNS. This is actually estimated charges. So if you want to pull out and see what your charges are going to be, it will summarize. And I did this. This is the total, so I will pay $17 this month. I had 3 instances running for friends. It's not too bad. Normally it's much cheaper, and I started off as such a cheapskate, but because things were kind of cool, I became that typical customer where I will actually pay a little bit more. So I'm paying almost $15 in resources for EC2. Route 53 is fine. S3 is fine. And I'm surprised I paid so much for data transfer, but that's fine too. So think about how dynamic this can be now. So you are accessing the things completely, not using things virtually and programmatically. So we are now able to get to most of everything that you want. And I'm running out of time, so I won't be able to demonstrate too much more. Let me recap a couple of things. Hardware, we just use for Boto, but we have virtualization in desktop. We also have virtualization in software, and that happens to be things that you're going to use, for example, a Bsd Jail. A Bsd Jail is actually a really clever idea. If you actually look at, I don't have a free Bsd instance running here, but I'm going to go over to OptLocal. If I were to go to the top of a Unix system, it would look very similar to this. Now, there's some extra Mac stuff that crept in here, but if you ignore that, and some Apache 2 stuff, most of this looks like the top of a Unix system. Bin, etc., include, live. In fact, it could be an exact version of a Linux system. FreeBSDs, especially FreeBSD jails, are, if you want to be able to make a different file system that's accessible from an outside service, you can make that version in a lower directory. Like, for example, I'm in OptLocal. You can do the same thing there, and it's perfect for an FTP service. So I'm going to simulate the file system for my FTP service, and it's going to be jailed. The kernel is never going to let me get out of that jail. It just, as security, will never let you. Well, unless you have root. Well, that's for FreeBSD, you might not be able to ever get out of jail. I have to think about that. But the point is, whenever someone's coming from an FTP, they're coming from outside. But if they compromise your system, they get to your file systems, they can't FTP outside. Even if they try to FTP above, the only thing the FTP service will ever see is this subdirectory, and it will look like a normal directory. So it's very much like if you do a change root. Sometimes if you change root, you say the root of my file system is off local. Then this process will see this is my root file system. So if I had a password, so if I had, for example, if I had such a file, which I don't, I could put the things I want in that file, mount this with the change root, so now this process actually is looking only at that root. Oh yeah, FreeBSD would be secure for even if that root on the actual file system was compromised, but change root would not be. Anyhow, I'm digressing. So the point is, I can have a virtual operating system as far as anyone's concerned from the outside service point of view. So as far as that guy who's FTPing into the box can see, he'll never actually see the real box, only the virtual box, if you will, the virtual directory and services available, and some extra stuff configured in the kernel for it. So these are very clever, that you have virtual environments. In fact, Python is very much the same way. If I wanted to, I have a Python environment, and so we'll demonstrate a couple of things. So we talked about the operating system virtualization, a free Bsd Jail, and I kind of sort of, not really, it's just more for demonstrations, but at least showed you what it would look like on Mac boards, but it's not really the same kind of virtualization. Well, there are other things, and the Python environment has been made so that it actually is virtualized in a sense. So there's this new PEP 405, which keeps things very virtualized. It's a very lightweight virtualization, so things aren't having to be copied around. And it's coming out in the new versions of Python. So if you want to just take a look, since we're short on time, take a look at this PEP. It's a very lightweight version. And notice that there's VENV, a new way of creating virtual environments that are lightweight. Things aren't necessarily copied. It's new environment variables to set up. Alright, so I'm quickly just going to talk about virtual environments with wrappers. The reason it's just easier to use Doug Hellman's wrappers to Ian Bicken's virtualenv. It's really just an extra couple of scripts that go on top of virtualenv. So here's a list of my virtual environments. And I'm going to just pick a virtual environment. Let's say I'm going to say Python 3.2. So I'm currently in the virtual environment of Glenn Jarvis because this is the one I was in earlier. If I go to Python, notice I'm on 2.7.3. I don't want to do that. I want to get out of this environment. This is a virtual environment command, a virtualenv command. And this is the virtualenv wrapper command. I am now going to go to Python 3.2. And now I'm in Python 3.2. So I can switch environments that easily. That's really handy if I want to see if a program's installed. I want to install a particular program and see what's going on. And then a program's put into the site packages. These things, this list that we just saw, this list of virtualenvs, it's nothing but just this directory of virtualenvs. This is where I've installed things. So if I look at Django 1.5, that's where the Django 1.5 virtual environment is. In fact, let's just play with that one. It looks almost like we're looking at a virtual machine as well, or looking like top of a Python, of a Linux directory. Bin lib includes. In fact, if I go into lib, hey, there's a Python lib. Inside of lib, these are all the Python libs. In fact, if I go to site packages, I see what's installed. So I could pretty much, this is all compartmentalized. Instead of having these in different locations, it's its own copy. So I can have things installed in this environment that's not in other environments. So cutting that one a little short, sorry for that. Virtualenv is easier, I think. I'm just going to run through the last pieces. By the way, my current employer is doing so many cool things with virtual environments. We're doing things with Zen and KVM and with Python, basically written completely in Python, along with many other things with VMware. So if you are remotely interested, here's some flyers, and I can just email me. I'll send you a flyer. Okay, so this is the end of the talk. A little blurb for fun. But basically, if you have any questions at all, feel free to email me. Hopefully what we did is take you through a basic understanding that virtualization is lots of different kinds, including virtualization for the desktop. We showed you how to connect to Amazon and actually go to Amazon and build a machine. We showed you how to do the same thing with Boto through some extra scripts. And then we showed you how virtual environments work briefly, just the idea. It's a little, very much like a free Bsd Jail. I wish I had more time to actually demo the free Bsd Jail part. Regardless, if you have any questions, feel free to email me. Good luck.